Today we're going to talk about the angle of elevation and angle of depression. Angle of elevation and angle of depression is basically just solving problems using trig like we have been doing for the past week. Only difference is now these are word problems and you're going to have to draw the triangle. Y'all, you have to draw the triangle. Part of getting points for these problems is drawing the triangle. So let's get started. Angle of elevation is the angle above the horizontal so the angle above the horizontal that an observer must look at to see an object that is higher than the observer. So for example, if we look, so let's say this is where our person is at. This is the person's line of sight, so this is the horizontal. And they're looking at an object. That should have been a straight line across, but we'll go with it. Say they're looking at the sun up here. So their angle of elevation would be this angle right here, from the horizontal, the dotted line, up to the thing that they're looking at. So this is the angle of elevation. So for example, you are measuring the height of a flagpole. You stand 19 feet from the base of the pole. You measure the angle of elevation from a point on the ground to the top of the pole to be 64 degrees. Estimate the height of the pole. Remember, when we talk about these, all of your pictures should be right triangles. That we're doing right triangle trig, so that means all of your pictures should be right triangles. So here's my right triangle. Let's say this is my flag. Let's make it an American flag. So you're measuring the height of a flagpole. You stand 19 feet from the base of the pole. So here's the base of the pole. So this is where you're standing. So that distance is 19 feet. You measure the angle of elevation from a point on the ground to the top of the pole to be 64 degrees. So angle of elevation goes from the horizontal line, so this line right here, up. So that would be this angle right here is our 64 degrees. And we're trying to find the height of the flagpole, so this is our x. Now this is just like what we did before. So we're going to label our O, our A, and our H, our opposite, our adjacent, and our hypotenuse. So remember, this is our right angle. Across from our right angle is always our hypotenuse. Across from the angle we know is our opposite. And right beside the angle that we're talking about is our adjacent. So in this case, we want to know our O, we know our A. So O and A, remember we use SOHCAHTOA to help us figure out which one we're using. So O and A is tan. So we're going to say tan of our angle, so our angle is 64, so tan 64 is equal to, it's O over A, so O is x, over our A is 19. When x is on top, we multiply. So I'm going to multiply both sides by 19. So x is equal to 19 times tan 64. That's what you're going to put in your calculator. Remember, your calculator has to be in degree mode. If your calculator is not in degree mode, it will not give you the correct answer. So when you put 19 times tan 64 in your calculator, it should give you 38.96. So this flagpole is 38.96 feet high. Let's look at another example. If the angle of elevation from your position on the ground to the top of a building is 67 degrees, and you are standing 30 meters from the foot of the building, approximate the height of the building. So once again, we know we're going to have a right triangle because this is our right triangle trig unit. So there's our right triangle. So this is our building. I'll put some windows in it. Y'all don't judge my drawing. Okay, so there's my building. So we know the angle of elevation from your position on the ground to the top of the building is 67 degrees. So this is you. You're standing over here. And you're looking up at the top of the building. So the angle of elevation goes from the horizontal line up. So that's this angle is our 67 degrees. It says that you are standing 30 meters from the foot of the building. So here's the foot of the building. Here's where you're standing. So that distance is 30 meters. And it wants us to approximate the height of the building. So this is x. So once we have that drawn, we need to label our O, our A, and our H. So across from our right angle is our H, our hypotenuse. Across from the angle we know is our O, our opposite. And then right beside the angle is our A, our adjacent. So in this problem, we want to know O, we know A. So what uses O and A? Tan. Remember SOHCAHTOA. So tan. So we're going to say tan of our angle. So tan 67 equals O over A. So O is x. Over A is our 30. Once again, x is on top, our variable is on top, so we multiply. So I'm going to multiply both sides by 30. And that gives me that x is equal to 30 times tan 67. So in your calculator, you're going to do 30 times tan 67. And that should give you that x is equal to 70.68. So the height of the building is 70.68 meters. These two examples just happen to both use tangent. That was just a coincidence. You could use any of the three trig functions, sine, cosine, or tangent. Okay, so angle of depression is very similar. So the angle of depression is the angle between the horizontal and the line of sight to an object but below or beneath the horizontal. So, for example, if you are up here, so if this is you, and so the horizontal line would be this way, but you're looking down at something, let's say a boat, that's way down here. This would be your angle of depression. Because it's going down, from the horizontal down. But let's think of this. I'm going to come up here where I have some room. So we have, let's say this horizontal, and we're looking down. And we know that this angle is the angle of depression. But then if we have this horizontal looking up, this would be the angle of elevation. If we think about this, our two horizontal lines are parallel. Because they're horizontal, they're never going to touch. So we have parallel lines cut by this transversal. What do we know about these two angles? We learned that back in, I think, topic 2. if we were to continue these lines out this way, it might help. Those are alternate interior angles. And we know alternate interior angles are congruent, which means our angle of elevation is equal to the angle of depression. Those are the same degrees. Let's look at an example of angle of depression. So the angle of depression is equal to the angle of elevation. And for example, an airplane is flying at a height of 2 miles above level ground. The angle of depression from the plane to the foot of a tree is 15 degrees. Find the distance that the airplane must fly to be directly above the tree. Okay, so let's say this is my airplane. So I'm going to draw an airplane. Yes, I know it looks like a fish. Pretend it's an airplane. And we're looking down here at the foot of a tree. So here's my tree. So my airplane is going to keep going this way in a straight line, straight horizontal line. So it says an airplane is flying at a height of 2 miles. So that means it's 2 miles above the ground. So this distance to the ground we know is going to be 2 miles. We also know this distance over here to where the airplane will be would be 2 miles. Those would be the same. We know the angle of depression from the plane to the foot of the tree is 15 degrees, sorry. So start from the horizontal and go down. That gives us our angle of depression. That is our 15 degrees. But remember, the angle of depression is the same thing as the angle of elevation. So if we want to think about it this way, so here's our ground. So we can say from the ground up would be 15 degrees. And so we want to know the distance the airplane must fly to be directly above the tree. So this is the distance we're looking for. If we use the bottom triangle, this is the distance we're looking for. So that's 2 different triangles that we could use that would give us the same thing. They're just turned a little differently. So the one that I think is the easiest to see, the one that I would use, is the one that looks like this, but it doesn't really matter. So that's my right angle. This one's my airplane. The angle of depression was 15 degrees. We know the height of the airplane was 2 miles. This is the base of my tree. And this is what I'm looking for. So now that we have our triangle, we can label our O, our A, and our H. So across from our right angle is our H. Across from our 15 degrees is our O. And beside our 15 degrees is our A. So this one, we know O, we want to know A. So what uses O and A? Tan. So we can say tan of our angle, tan 15, is equal to O, which is 2, over A, which is X. X is on bottom, which means these switch places. So I get X is equal to 2 over tan 15. So that's what you put in your calculator. 2 divided by tan 15. And it should give you that X is equal to 7.46. So once again, all of these ended up using tangent. That was just a coincidence. That will not always happen. You can use any of the 3 trig functions, sine, cosine, or tangent, to solve these problems, depending on what's given to you.